All right, so we're going to move on to polar coordinates. So polar coordinates, we have really just the polar axis. And so when we're moving a distance of theta and a distance r out, this xy point here, right, we're going to superimpose the xy axis here. And so if we're looking at this x value here, right, this distance of x, this is equal to cosine. Let me just write this up. Cosine of the angle theta would be x over r. So r cosine theta is equal to x. So that's what the x is equal to, is r cosine theta. So this xy point right here would have this height of y. So we would have sine of theta is equal to y over r. So our sine theta would equal to y. And so that's what this is. And tangent of theta is y over x. And this is all talking about the circle, x squared plus y squared equals r squared. Okay. So let me get rid of all this. This is just giving you a little bit of development. I'm sure you've seen this before in pre-calculus. Okay, so we want to find the slope in polar coordinates. So just like before when we wanted to find y prime and we were in parametric equations, we took the derivative with respect to t of y, and we took the derivative with respect to t of the x. So now we're going to take the derivative with respect to theta of the y and the derivative with respect to theta of the x. So this time the r is a function, so it's going to be much more challenging, so that I've got to have derivative of r cosine, so I'm going to have product rule. So first d second plus second d first, and then the derivative of r cosine theta will be first d second, so that's where I get the negative sign, plus second d first. So this long thing is slope in polar coordinates. Oops, I don't know what that is. All right. Okay, so let's go find it. So y prime is going to be, I'm just going to write this down, knowing that this is what r is going to be, and then let me figure out what dr d theta is. So the derivative of this will be 3 cosine theta. So notice, so this dr d theta, which is 3 cosine theta, goes in right here, right? And then this r is going to go right here. So this equation explodes into this huge thing. So slope in polar coordinates is a very big quantity. All right, so here we go. So first off, I'm going to put in r. So 2 plus 3 sine theta times the cosine of theta plus sine of theta times my dr d theta, which is 3 cosine theta, all over negative r sine theta plus cosine theta times my dr d theta. All right, almost every single time there is not a nice, there is not any simplification that can go on in here. So if you're given an angle of theta, just go use it. So don't spend any time trying to simplify this, find identities, anything like that. So let's go plug in theta. So y prime will equal, so put in pi here, I'll get 0. And put in pi into here, I'll get negative 1. Put in pi here, I'll get 0. So I was going to put 0 for effect there. Substituting in pi here, there's 0. So I have negative 2. Oh, times another 0, right? Plus, substituting pi, both of these are negative 1, so I get a positive 3. So I get a negative 2/3. So on this graph, the slope of the tangent line at theta equal pi is negative 2/3. All right. So, how do I find when the tangent line is horizontal? Tangent line is horizontal means y prime equals 0. So that's going to be where the numerator equals 0. All right, unlike in the when we did parametric equations, there were times that there were canceling from the numerator and the denominator. There is not going to be canceling on these. So we can go right to finding out when the numerator equals 0. So that means I'm setting r cosine of theta plus sine times dr d theta equals 0. Okay, this is r, so I want to find dr d theta, which is cosine, and substitute that in. So r is 1 plus sine theta times cosine of theta plus sine of theta times cosine of theta equals 0. Okay, remember, never ever divide through by a trig function or a variable for that matter, because you lose answers. So from this side here, I want to factor out this cosine. So pull it out here. Okay, so what's left if I take away this out of this whole term? I'd be left with a 1 plus sine of theta. And if I factor out cosine out of this term, I'd be left with a sine theta. So equaling 0, so I have cosine of theta times 1 plus 2 sine theta equaling 0. So I've got two quantities that equal 0, and I'm just looking between 0 and 2 pi. So cosine of theta equals 0. That will happen at pi over 2 and 3 pi over 2. And sine of theta equaling negative 1/2. That will equal to 7 pi over 6 and 11 pi over 6. So those are the four angles.